determine the coordinates of the stationary points of y. So it says y equals x cubed minus 3x squared plus 2. Then it says this question also says find the second derivative of y and hence determine the nature of each stationary point. Alright, so you would have done that this type of question before. So I want you to pause the video and make an attempt at this question. Okay, you've paused the video and you attempted this question. What did you get? Right, let's discuss it. You're going to determine the stationary points of y. Now remember, if you, for example, suppose this was the graph of the function, the stationary points would be where the gradient is equal to 0. Now, here the gradient would be 0 because it is horizontal, and right here too would be horizontal. Alright? So you would have a local maximum point here and a local minimum point here. And remember, the reason why they call it local is because while it is a maximum point within this region, if you should go too far, then you see a point that is higher than that maximum. So you have to remain within a certain locality in order for it to remain a maximum point. You don't want to see other points higher than it because it would no longer be a maximum point. And it is a local minimum because within a certain region it is a minimum point, but if you stray too far, then you find other points that are below it. So it would no longer be the minimum point. So you have to remain within a locality for it to be a minimum point. Alright, so here now. Remember, when you differentiate a function, what you get is called the derivative or the gradient function. It tells you what the gradient is at that point. So if the gradient is 0, right, it means you differentiate, get the gradient function and make it equal to 0. So you're going to differentiate this function. You find dy by dx equals, shortcut method, this would be 3x squared, or the power rule I should say, 3x squared minus 326, 6x. Alright, that's it. And you make that equal to 0. Now what are the values of x? Because I see it's a quadratic function, so there will be two values. Factorize. You get 3x outside the bracket. Inside the bracket, you get x minus 3 to the 6, 2 equals 0. Right. So when you solve this, the values are x equals 0 and x equals 2. Right? X equals 0 and x equals 2 would be the stationary points. You see that? Now, here you're asked to determine the nature of each stationary point from the second derivative. Now, here, what you're going to do is find d square y by dx squared. So you differentiate again. It would be 326x minus 6. It's 6x minus 6. Alright? Now remember, alright, we'll talk about that at the end. We're going to talk about how you determine whether a point is minimum or maximum. Now, if you substitute, like x equals 0, d square y by dx squared would be equal to 6 times 0 minus 6, which is negative 6. And then if you let x equal, what is the other value again? 2. Let x equal 2, then d square y by dx squared would be equal to 6 times 2 minus 6 is 12 minus 6 is what? 6. Alright, so here this is a it's a negative value. Negative, therefore what we have, and this is a positive, therefore what do we have? Let me rewrite this 6 properly. This is a 6. When we have a negative value, it means you're turning from a high to a low. It means what you have here, you are going this way. Your gradient would be, your tangent would be swinging downwards like that. So you would have a maximum point, right? And then if it is positive, it means your tangent line, the gradient of your tangent line would be rising, increasing, so it would be swinging upward. So that means you have a minimum, maximum point, minimum point. All right, now they didn't ask you to sketch it, but suppose you should do a little sketch of the function. Then you would say you have 2 points, maximum, minimum. You'd have to find the y coordinates as well if you should sketch it. When x is 0, you'd have to say when x is 0, what is y? When x equals 0, y equal, and when x equals 2, y equals. When x is 0, y would be 2. X is 0, y equals 2. When x is 2, y would be what? This would be 8 minus 2 2's 4, 4 3's 12 plus 2. Right? So you would have 8 minus 12 is negative 4. Negative 4 plus 2 is negative 2. So y would be negative 2. Now, here, x is 0. That's a maximum point. And x is 2, minimum. So if you should sketch it, what you would have is x equals 0, y is 2 right here. You have a maximum point, and then let me redraw this. X is 2. When x is 2, y is negative 2. So 2, negative 2. It would be like this. You have a minimum point. So I expect it to look like this. Now, let us see if we can get a graph of this function. What would a graph of this function look like? Let's go for GeoGebra, a graph plotter here. The function is y equal x cubed minus 3x squared plus 2. X cubed minus 3x squared plus 2. X cubed minus 3x squared plus 2. Let me show the grid. Maximize this. X squared, x cubed. So we have x raised to the power of 3 minus 3x raised to the power of 2. Let me just look back and confirm. X cubed minus 3x squared plus 2. So it's x cubed minus 3x squared. In fact, let me resize this thing. Make sure you can see everything here. Yeah. X cubed minus 3x squared plus 2. So let me make this line thicker. So this is our function. You see it looks like the function that we had plotted. 0, 2 maximum, 2, negative 2 minimum. At 0, 2 we have maximum, 2, negative 2 minimum. So the graph would look like this. Alright. Okay, so we did more than we were asked to do. But the important thing here is that they ask you to find the coordinates of a stationary point. You should know to do that. And to determine the nature of each stationary point.